Hello and welcome to this look at how to explain observations that are given to you using electropotential data that you're provided with. And the exam question we're looking at is quite unstructured, its format. So the redox system data is at the top, obviously. It says what the student does. They warm a mixture of methanol and acidified potassium manganate 7. So the first thing to do is to identify the two redox systems that contain those species. So looking at the electropotential values, the electropotential value for redox system 2 at minus 0.03 volts is more negative than that for redox system 4 at plus 1.51. So therefore the position of equilibrium redox system 2 will shift to the left and the P or E for redox system 4 will shift to the right. So redox system 2 in doing that will produce HCOOH, which then feeds into redox system 1. So for redox system 1 to produce carbon dioxide gas, which would explain the gas bubbles, it has to also shift from right to left. So therefore, redox system 1's electropotential value is also more negative than that of redox system 4. So redox system 1 will also be reversed. And you will end up with carbon dioxide gas being given off. So we've done the electropotentials and equilibria part. What about the equations? So I'm going to build the overall equations, then go to the mark scheme and take you through how I did it by reference to the mark scheme as well. So just what I'm doing here is I'm multiplying up the two half equations so that the electrons cancel. Then I'm combining them, taking account of which one has the position of equilibrium shifting to the left, so in other words which one reverses and which one stays as a reduction. And then I cancel out any excess water or H plus that turns up on both sides of the equation. So you've got redox systems 2 and 4, which is the initial reaction, and then redox system 1 and 4, which is the second reaction. So if we have a quick look at the mark scheme, just before we do that, I just want to recap on what I multiplied up. I had to multiply the things with 2 electrons by 5 to make 10 electrons. So I could multiply up the redox system 4 by 2 to make 10 electrons. So it's all based on how many electrons I have. So there's 5 electrons being gained in redox system 4, so that is doubled to make 10 electrons, everything else being doubled around it. And then in redox systems 1 and 2, they had to be multiplied 5 times to make 10 electrons. So everything else around them is multiplied 5 times. So to recap the technique I used, you multiply one or both half equations to cancel electrons. Then you decide from the electropotentials of the two half equations which one has a position of equilibrium shifting to the left, so you'd say it in terms of the equilibrium shift. Then you combine the two half equations together and you get rid of any electrons, and you also cancel H plus and H2O that turns up on both sides. Okay, thanks for listening. Until next time, see you soon.